Okay, so it's much, much easier to think about things in 3 dimensions using vectors. Okay, so this is what we're going to start looking at today. We're familiar with how to look at vectors, how to look at coordinate geometry or equations of lines in 2 dimensions. It's of the form y equals mx plus c. Now let's dig into this a little bit more to see what's buried behind here. Let's think. Are you happy that x and y is just simply some point that lies on the line? Yeah? It's literally saying, for example, y equals 3x plus 5. It's literally saying, find me the set of points which have a y coordinate, which is 3 times the x coordinate plus 5. Yeah? And you just simply join them all together, right? Now, let's think about what's going on here. So, what does the m stand for? What does the m stand for?
Gradient.
It's gradient. Fantastic. Now, if you didn't know what gradient was, what is that? What is gradient? How would you describe gradient to somebody?
How quickly they move?
Absolutely, it's how quickly something changes, yeah? And we're familiar with that because we've looked at differentiation. That's literally the idea of looking at gradients.
But isn't the same thing in differentiation? In differentiation, we say look at how a function changes.
Yes, exactly. So gradient is all to do with the rate of change. It's how quickly something is changing at a particular point. Okay? Good. If you like, a gradient, because I'm trying to relate it back to vectors, a gradient is a bit like a direction, yeah? Steeper the gradient, change the direction, okay? So a gradient is a bit like a direction. Okay. What about the c? What does the c stand for?
Constant.
It is a constant, but it actually has a relationship to this graph. It's the intercept of which axis? This one, the vertical one, right? So the y-intercept. Okay, so it's literally just saying where does it cross the y-axis. So in other words, it's how high or low that line is. Does that make sense? Yeah? So if you like, if you want to relate it back to a vector, this is a bit like a position. It's almost like a starting point. Does that make sense? So y equals mx plus c, really it's composed of 2 parts. It's composed of a direction part, in other words a gradient, how the line's facing, how steep it is, and a position part. So in other words, how high or low that line is. Is that okay? So this is what I need to think about when I'm trying to come up with a vector equation of a line. Does that make sense?
For the graph on the board, the c should be 0, right?
For the graph on the board, absolutely, because it crosses 0. But it's still got a y-intercept, it's just 0. Yeah? If it was y equals 3x plus 5, which is what I had before, the gradient would be 3, means every time you go across by 1, you go up by 3, and it would be 5 high. So in other words, crosses the y-axis at 5. Is that okay? Yeah. Good. So I need to think about this with regards to this. So let's suppose, I'm going to do it in 2 dimensions first, and then hopefully you can see how it would apply to 3 dimensions. Let's suppose I give you 2 points. So here are the 2 points which we're going to do. Let me unfreeze this first. Okay, so let's have a look at these points. So let's have a look at part 1. So you have A is 1, 1, and what's B equal to?
6, 4.
6, 4. Okay, so what I'm going to start by doing is plotting these on a coordinate system. It's 2 dimensions, so let's put these on a coordinate system. So something that looks like this. So A is going to be at 1, 1, 1, 1, there's A, okay. And B is going to be at 6, 4. So 6, 4 over here. Okay? Now what I'm trying to do is find the equation of the line passing through these 2 points. Now I'm not interested in the Cartesian form. I'm not equals 1, y equals mx plus c. I'm not interested in that. What I'm trying to do is do this using vectors. So the first thing that I need is a position part. I need to actually get onto the line. Okay, I need to get onto the line. Are you happy that there's 2 vectors I can use to get onto the line? Yeah? I can either go from the origin, because remember I'm starting at the origin, that's how the coordinate system works. I can either go from the origin to A, or I can go from the origin to B. Does that make sense?
Line, can you tell repeat the last sentence I couldn't follow?
Okay, so all I need to do is get onto the line. Okay, all I need to do is get onto the line. I have 2 ways of getting onto the line.
Okay.
Either going from the origin to A, or the origin to B?
Yep.
Because remember with a coordinate system, you always start at the origin. Like literally x, y means move from the origin x across and then y up.
Sure.
Yeah, okay. So I'm just going to use A. I'm just going to use A, okay. So what would the vector be that gets me to A? So what would the vector be that gets me from O to A?
1.
It's just 1, 1, isn't it? Remember, this is a point. This is a point. So my vector would be 1, 1. Literally means move 1 across and move 1 up. Make sense? Okay. So this is my position vector. In fact, just to make it a little bit clearer, I'm going to label it with a little letter A. Okay. So my little letter A just means it's a position vector. It's a vector that gets me from the origin to the point A. Okay. And that's just 1, 1 in this case. Okay. So that's that bit sorted. I've done my position bit. Okay. What else do I need?
Also be gradient.
I need a direction vector. Yeah, exactly. I need a vector that moves me in the same direction as this line. Okay. So look, I'm sitting here at A at the moment. I've moved from the origin to A. Would you be happy that I already know a vector that moves in the same direction as this line? It's the vector from A to B. Yeah? So my direction vector will be from A to B. Okay? It's just going to be some distance in the direction of A to B. I just need any vector that moves in the same direction as this line. What would the vector A to B be equal to?
I mean, then 0 to B, there will be another vector, then we will find A to B.
Good. So I need to just get from A to B using any path I know. Well, why not go backwards along A and then forwards along B? Does that make sense? So watch it. I go from A to the origin, then from the origin to B. Okay? So in other words, this is going to be A to O, okay, from A to O, and then O to B. That would be the vector that moves me in the direction A to B. Okay? Now have a think. A to O, if I've said that A is little a, is O to A, what's A to O going to be? Well, negative, yeah, let's negative A. So negative 1, good. Okay. What's O to B going to be equal to? It's just going to be B. It's the position vector of B. Okay. Or if you like, I could write this as B minus A. Is that clear to everyone? Do we all follow that? Okay. So in other words, this thing up here is my position vector. That's the thing that gets me onto the line. Okay. This thing down here is going to be my direction vector. Okay. So now it's just a case of putting it all together. Okay, just putting it all together. Just remember, I need a way of getting to any point along this line. So let's suppose there's some random point out here. I'm going to call it R. Okay, where R is the position, is the vector that gets me from O to R. That point there. Okay. I'm just going to find a way of getting to that point. Well, this is how I could do it. I could move from O to A. Okay, so in other words, R is going to be moving from O to A. Okay, which I could write as A if I wanted to. Okay, and then I just need to move some multiple of this direction vector. Because remember, this direction vector moves in that direction. Okay, well, it just so happens that this point over here at R is just going to be a little bit further along. It could be twice the distance, could be 3 times the distance. It's just going to be a bit further along the distance from B to A. Does that make sense? So this is my direction vector. Okay, this one from here to here, from A to B. Okay, this point R is just going to be some multiple of A to B. It's just going to be parallel to it. Yeah, so it could be twice as far, 3 times as far, 4 times as far. It's just going to be some multiple of it. Could even be in the other direction. It could be like negative 2 times as far. Yeah. So in other words, I'm going to move some multiple of this. I'm just going to call it T. That's my multiple. Could be 3, could be 4, could be negative 5. Okay, it's going to be some multiple of A to B. Okay, which means there's going to be T lots of, well, A to B is given by this, B minus A.
So we have direction, then R.
So this is my position. This is the thing that actually gets me onto the line.
Yeah.
Remember, this could be B, this could be some other point that I knew lie on the line. I've just chosen it to be A.
Yeah.
Okay, and this thing here is my direction. This is the thing that moves me in the same direction as that line. And because I'm moving some multiple of that direction vector, could be 3 times as far, 4 times as far, 5 times as far,
So,
that's going to get me onto that point.
so we have position vector plus direction vector, we have the equation.
Exactly, but it's really important you've got that scalar there, because changing that is going to get you to different points along this line, which is again the whole point of this. I'm trying to get to different points along this line. Okay, and R, remember, is just O to R. I should write that. Okay, so you can either remember this or you can remember this, but this is the vector equation of a line in general terms.